Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Hadi Fian Malik, and I'm from Group 13. Me and my friend will gonna talk about type of solution for system of linear equation, many solution. This type of solution there's three, which is unique solution, non-solution, and many solution. In this video, we're gonna focus on many solution. Alright, the first thing you need to know to determine whether the solution is many solution or none is, which is row A equals to row A and B minus less than number of variable. Alright, let's move to the example 1. The first thing you need to do is put all the equation into the metric form, which is we get this, and then we perform ERO to get equivalent matrix. Okay, to get the equivalent matrix, we need to change the 1 here into 0. So what I do is row 2 minus row 1. So we get 0, 1, 2, and 1. And for the row 3, we need to run row 3 minus row 1, which is we get 0, 0, k square minus 4, and also we get k minus 2. Okay, when we talk about many solution, we need to get PA and PB is equals, and also we need to get them less than number of variable. Number of variable here is 3 because they have x, y, and z. When the row A and B is less than number of variable, so which means the row A and B is less than 3. So it can be 1 and it can be 2. After that, the first metric here is the PA here is 3 and the PAB is 3 also. So when we do the ERO, we get this metric, and then we're gonna assume the bottom here is 0 because we need to get less than 3. So we will assume all below here is 0. So we can get the row A is 2. Row A is here is 2, and row NB, which means all of this is 2 because we already assume all of this is 0. When we have assumed all this is 0, then we can get k square minus 4 is 0, and k minus 2 is 0, and then we get k equals to 2. I think this is on my part, and now I will pass it to my friend Pishan.
Next, this is Vishen here, and I will be explaining for the example 2. So now, it is given the system of linear equation, which is 4x plus 6y plus kz equals to p, x plus 2y minus 3z equals to 4, 3x plus 5y plus 6z is equals to 10. Now, the question is, find the value of k and p so that the system has infinitely many solutions. So first of all, we will convert the systems of linear equation into matrix form. So we will get this matrix form. Okay. After we have done this, now we will perform ERO to obtain the echelon matrix. So first of all, we will be doing negative B1 plus 4B2, which is negative row 1 plus by 4 times row 2, and we will also be doing negative 3 row 1 plus 4 row 3, and this is what we will get. After we have gotten this, we will be doing negative B2 plus B3. Once we have done that, we will obtain this matrix form. Once we have obtained this, to get the echelon matrix, we will be doing 1/2 times B3. And once we have performed that, we will get this matrix form. So from this, we can already find whether the system has infinite solutions or not. Okay, we know that for the system to have infinitely many solutions, row A and row A and B must be lesser than the number of variables. Therefore, we can assume that K is equivalent to 18 and P is equivalent to 12. Now we insert the value that we have assumed, then our echelon matrix will be this. So from this echelon matrix, we can find out that our row A is equal to 2 and our row A and B is equal to 2. Now our row A and row A and B is lesser than the number of variables, which is 3. Thus, this system has infinitely many solutions. Ta-da!
Alright, now I will explain the next example, which is example 3. So before I start, my name is Reza Izul Hadari bin Rizalman. So the question is, solve the following system of linear equations by using Gauss elimination method. So for the first step, we need to convert the system above into matrix form. So this is what we will get. Alright, for the second step, we need to perform ERO to obtain the echelon matrix. Alright, for this case, the first row and first column, the leading one is already here, so let's just move to the second row. Now we need to make the entries below this leading one to become 0. So let's make negative row 1 plus row 2. So this is what we will get. And then for the third row, we will need to make these entries below this leading one to become 0. So let negative row 1 plus row 3, and this is what we'll get. So basically we have obtained the echelon matrix, and now we can determine the rank of matrix. So the PA is 3 and PAB is 3, and the number of variable, as we can see, is 4. So basically PA equal to PAB and less to number of variables. Therefore, the system has many solutions. Now for the last step, we need to find the solution. So firstly, we need to choose the free variables. So basically, free variable is a variable that does not correspond to a column with a leading one when the matrix is in row and column form. So in this case, let's just choose W as a free variable. So let W equal to K. So just substitute it into the equation, and we will get x plus y minus z plus k equal to 7, and y equal to 8 minus k minus z, and z equal to 10 plus k. So now we can find the solutions from the equations we get. So just do the substitution so we can find the value of x, y, and z. So as you can see, this is what we will get. So w equal to k, z equal to 10 plus k, y equal to negative 2 minus 2k, and x equal to 19 plus 2k. So for the answers, we can just write it as like this. And therefore, k are element of real numbers. So that is all from me. Thank you.
So, we have come to the final example of our topic in this video, which is example 4, which will be explained by me, Hilmi. Solve the following systems of equations by using Gauss elimination method. So, from this system of equation, the first step we have to do is convert the systems of equations into matrix form. As you can see here, from 2x plus 4y minus 2z equals 4, I have converted to like this: 2, 4, negative 2, 0, 4, 2, 4, negative 1, 2, 7, 0, 0, 1, 2, 3. And each column represents the unknowns, alright? And second, we have to perform ERO for the matrix form here to obtain its echelon matrix. So what I've done here, the first step which I have done here is to obtain the leading one for the second row, where I multiply negative 1 for the first row and then adding up to the second row, which I get here. The second row will change to 0, 0, 1, 2, 3, while the first row and the third row remain unchanged. Then I have to get rid to ensure the third row to become 0. So in order to achieve that, I multiply negative 1 for the second row and add up with the third row. So I will get all of the third rows to be 0 here, but we have another one thing left to do, which is to get the leading one for the first row. In order to achieve that, I multiply 1 and 1 over 2 to the first row, and hence I have finally achieved the echelon matrix here. Once I have reached this, I can know the rank of matrix for both row A and row A and B. So as you can see here, row A is equals to 2. See here, 1, 2. And row A and B is also equals to 2. 1, 2. So since row A and row A and B is the same, is equal to each other, and it is less than the number of variables, which is 4, this system has infinitely many solutions. But this is not done yet. We have to find the solutions too. In order to find the solutions, we have to choose the free variables from the echelon matrix above. So to find the free variables, we have to choose the column that has no leading ones. So for example, for the x column, there is a leading one, so we cannot choose that one. For y, there is no leading one, so y can be our variable. Z, there is a leading one on the second row, so we cannot choose it. And w, there is no leading one, so we can choose w as our free. So as I said just now, w column can be our free variable as it has no leading one on it. So our free variables can be y equals to k1 and w equals to k2. So from here, we can substitute our free variables here into the equations obtained from the echelon matrix above. So therefore, x plus 2y minus z equals to 2, we substitute with y equals to k1, it will become x plus 2k1 minus z equals to 2. This is our first equation. And the second equation, z plus 2w equals to 3, will be substitute with w equals to k2, it will become z plus 2k2 equals to 3. Therefore, we have to change it to z into z terms, which is z equals to 3 minus 2k2 in order for us to find the value of x. So it will become x 5 minus 2k1 minus 2k2 here. Hence, we can now know the solutions for the system equation, which are x equals to 5 minus 2k1 minus 2k2, y equals to k1, z equals to 3 minus 2k2, w equals to k2, where k1, k2 are an element of R.